All right, so today we're going to look at linear versus arithmetic sequences. How do you know a context problem is linear or arithmetic? Please go ahead and make this correction to these notes. It says linear function is either discrete or continuous and is defined for all real inputs. What that means is it can include fractions, decimals, and is graphable as a connected line or a dotted line. So basically linear can be both. An arithmetic sequence is only a discrete model. It's used when inputs increase by whole numbers, like time intervals or session counts. It does not connect. All right, so let's take a look at some questions. I'm going to do question number 1. Please go ahead and do question number 2. Okay, so it says Jasmine deposits $10 into her savings account every month, starting with 50. Okay, so because this has a start and then it keeps happening, this is definitely a linear function. So let's go ahead and write in number 1 is a linear function. If I've said it's linear, here's my equation. I need to know what's the number that keeps happening and then what is my y-intercept, my start, the number that happens one time. So if I'm depositing $10 into my savings account every month, what does that mean? Month 1, I deposit $10. Month 2, another $10. Month 3, another $10. Month 4, another $10. Month 5, another $10. So this is the number that keeps happening. Now, think about this number. Is it going to make my total go up or go down? Because I'm putting it into the bank account, it makes it go up. So this is a positive. So my M is going to be positive. Since I'm saying I'm writing it in 9th grade as a linear function, I'm not going to write Y equals. Let's use J of M. Letters don't really matter as long as you know what they mean. So J of M, 10 is positive. And now because I used M instead of X, I'm going to change X to lowercase m. And then what is my start? What is my initial? What is the number that happens one time? It says starting with $50. So that's the number that happens one time. All right, so that's just a quick recap of how to write a linear function from context. Now what we're going to focus on is what we've learned. Is it discrete or continuous? So remember, a linear function can either be discrete or continuous. So all I need to know is basically, can I have fractions, decimals, or is it just any number? Okay, so if it's discrete, no fractions. If it's continuous, everything. So if I'm depositing $10 into my account every month, so that means, just like I said before, month 1, month 2, month 3. Am I depositing something in month 1.5? No. Because I'm not depositing something in month 1.5, that means this must be discrete. This is time, this is months. Remember, time is always on your x-axis, and this is money in account. So as soon as I find one of them is discrete, the whole thing is discrete. If months could work to where it could be decimals, then I would check the y-axis and see if the money in the account was discrete. But since months is already discrete, I'm going to stop right there. Why is it discrete? Jasmine doesn't make deposits in month 1.5. Okay, just something like that. That's fine. All right, so what is my function? So I wrote my function here. I really didn't have space. So this right here is, I'm going to say, I'm actually trying to say, is this, what is the explicit or function, depending on what you start with. So what I mean by that is, if you start off with a function, I want you to write the explicit notation here. Let's take a look at our formulas, and I'm looking for my explicit formula, which is right here. What are the key things that I need? I need a sub 1, which means my first term, and I need d, which means my common difference. Okay, so a sub 1 and d, which is my common difference. I'm going to write it in this space right here. A sub 1, my very first term, is not my 0 term, and I'm going to show you in the calculator what I mean by that. So I'm just going to quickly put in our function. Okay, see the error. What's the problem? Try adding y, because it's really, I should have just written the J of M, but nobody has time for that. You could just put X instead. So you can write it in 8th grade or you can write it in 9th grade. So this is my function, right? I'm going to make it a table so I can see, because I'm looking for my first term, not my 0 term, which is my y-intercept, but my very first term, which is 60. So that's the big difference between arithmetic sequence and linear. And we're going to go ahead and say this again. Linear starts at x equals 0. Sequence starts at a1 or x equals 1. however you want to kind of visualize that. So if I was trying to write my equation, I would go to 0 for my y-intercept. But if I'm writing a sequence, I go to my first term, which is what? 60. So my first term is 60. And then my common difference is my slope. So to go from linear to sequence, all I need is my common difference and my first term. So what is my slope? Here is my slope right here. It's 10. So my common difference is 10. A sub n, so A sub n equals A sub 1, which is, what do we get? 60. Okay, plus D, so I'm going to say plus 10, parentheses n minus 1, parentheses n minus 1. Okay, so A sub n 60 plus 10 n minus 1. So now I've just gone from function notation into, okay, explicit form. Now my next question is evaluated at 12. So my input is 12. I only go as far as two ways I can do this. I can go to the very bottom, press enter, 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 enter till I get to 12. And I like doing it this way because sometimes when it gives me my output and as for my input, if you just type in the number, it will no longer do enter. You have to delete it and start again. So f of 12 is 170. Because I labeled it j, I'm going to go j of 12. So j of 12 is equal to 170. So basically what is this saying? After 12 months, which is a year, she's going to have, Jasmine, yeah, she's going to have $170. All right, go ahead and pause the video and complete examples 2 and 4. All right, let's take a look at another example. So now I'm going to do, so I started off with a linear one. Remember, linear has a start and a change, change, change. If you look at this question right here, it says Michael walks 3 miles on Monday, 6 on Tuesday, 9 on Wednesday. Okay, so let's start creating a table. 3 miles on Monday. So Monday is day what? 1. It is not day 0, so he walks 3 miles on day 1. The first day he walks 3 miles. On Tuesday, which is going to be day 2, he walks 6 miles. On Wednesday, which is going to be day 3, he walks 9 miles. So this is X, this is Y. I'm just copying down 1, 2, and 3. And this is going to be 3, 6, 9. Okay, there is no start and a gradual increase. So this is a sequence, is an arithmetic sequence. Okay, because it doesn't have a start and a number that keeps repeating. It just starts on day 1 and then goes to day 2 and then goes to day 3. It is a pattern. It is a sequence. So now that I know that that is a sequence, so remember what I said. On the first box, I want you to write whether the function or the sequence. So in this case, it's a sequence. So I'm going to write what is the sequence in explicit form. So here is my formula. So it says A sub n equals, what's my first term? My first term, my number 1 is 3. All right, so this is 3 plus my common difference. So what's my common difference? And how do I find my common difference again? So D is equal to my second minus my first. So D is equal to, what's my second number? 6 minus my first, which is 3. So 6 minus 3, which is 3. So that's my common difference is positive 3. So back to this, my first term is 3 plus my common difference. So this is plus 3, parentheses, and then what do we have? N minus 1. Boom. So that is that in explicit form. Okay, so now that I have that in explicit form, I know that automatically I don't even have to think about the question. All sequences are what kind? They are discrete models, right? So I already know that this is discrete. And why is it discrete? Because it's a sequence. And I'm just going to write SUQ dot, okay, because of sequence. All right, so now that I have my explicit form, this box is just to transform it into another form. So I'm going to transform this from explicit into function. So if the question gives me function, I'm going to write it in explicit. If it gives me explicit, I'm going to write it in function notation. All right, so function notation. What do I need for function notation? So I'm going to come right back here. For function notation, I need my slope and I need my y-intercept. So I'm going to write it in this box here so we can see. So my slope, remember, is the same as my common difference. So slope is the same as common difference, D. Okay, slope and common difference are saying the exact same thing, how it changes each time. So with that being said, m is equal to, what's my common difference? So let's go back to the formula and see where it is. So it's right before the parentheses, so my common difference is 3, so m is 3. All right, then my y-intercept, so y-intercept is when x is equal to 0. It is not my first term. Okay, let me say that again. My common difference is when x is equal to 0, not when x is equal to 1. So my y-intercept is not 3. What that means is I have to go back 1. Okay, so instead of going back 1, I'm just going to come right here, and I'm going to write y1 squiggly line, and I'm using 1 because there's 1s right here. mx1, because again, there's a 1 right there, plus b, so it can tell me my linear regression line. So now I'm going to write it out. So this is y equals m, which is 3, x plus 0. So that's my equation. It's gone through all my dots, so I know that this is right. So again, let me remind you of page 1 and 2. Those are my dots. I type this in, which is right because it goes through my 3 dots, and this goes over my green line. Perfect. All right, so now that I have this, I can make this a table, and I can see that my 0 is 0. Okay, so my start is 0, or you could look at it from my y-intercept. My y-intercept is 0. So whichever one is easier for you, please go ahead and do that. So again, I just want to emphasize the difference between sequences and function notation is that sequences starts at 1. This is my first term, whereas function notation starts at x equals 0. Okay, so you can see my first term is 3 and my y-intercept is 0. All right, so now that I have that, let's go ahead and write this out in function notation. What do I want to use? Michael is walking, and these are days. So I can use MD, but again, it doesn't matter what letters I use. Okay, it's okay, as long as you're keeping track. So M of D is equal to M, which is 3. And now because I didn't use X, I'm going to say D plus 0. And I don't have to write the plus 0. I could really say M of D is 3D. Okay. All right. Now that I know that, let's evaluate it for M of 12. This is really cool because I already have the table here, so I can just press enter, 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 enter. So M of 12 is equal to 36. Let's practice.